Now let's jump in and talk about deploying and exploring applications that we've deployed to a Cloud Foundry environment. Really talk through what does it mean to push an application, what kind of configuration settings are available to me, and what does it mean to manage this at runtime. So we start with the YAML manifest, the YML files that you see. Really, and if we go back to the 12-factor app guidance, it's about defining dependencies clearly, and that's really a lot of what this is. It describes the push activities. It tells CF push, which is the command you use to push your application, what to do with the app. It includes everything from how many instances to build, how much memory to allocate, which service instances to use. That manifest helps you automate deployment, makes it very repeatable, especially when you have multiple applications. You can imagine all the benefits of this. It's consistency, it's reproducibility. If I want applications to be portable between different clouds, a manifest is super useful for making it very consistent. The attribute values on the server actually at any one time represent kind of the composite of all the different settings applied to that point. Things in the manifest, flags you pass in at CF push, any commands you issue on the go. So there's just a whole set of values of which manifests feed into that represent the state of an application when it's running. When you do a push, it actually looks for, CF push looks for a manifest locally, the manifest YML file. By default, it'll deploy an app using that file in the current working directory. I can actually use a -f option and provide a non-standard manifest location or file name. So I might put it somewhere else, I might name it something different. If I choose to do that, I can use the -f command when I push, and it'll go ahead and find it. There are required and optional parameters. Required is pretty lightweight. Really, you just require an application name, and that you can provide in the manifest or even the command line. I don't even need a manifest technically to deploy an app, although it makes it much more consistent. And the command line always trumps what's ever in the YAML file. But when I push an application for the first time, CF applies any default values to attributes that you don't include in the manifest. This might be memory size, number of instances. All those things have default parameters that if you don't explicitly set them, they'll be obviously set as you do a push. So you can set all these optional parameters that we'll talk about in just a moment. What's pretty cool is that this also works in a multi-app environment, so I can describe multiple applications, use an inheritance model, and even have shared properties, and we'll talk through those now here in just a moment. But I can use a single manifest file to describe an actual set of apps that make up a system and maintain things that way, which is pretty handy. So let's explore the manifest. We'll talk through each of the different types of parameters. First, the required attributes. That's about it. I have to provide a name. Every manifest starts with 3 dashes at the top. I can put comments in there with a hashtag. I can set then applications and then a space in, have a dash, name, colon, and the name of my application. This is important. This has to be globally unique, at least in any environment, because again, this is a multi-tenant environment that everyone is sharing at least a domain. So if I have my own domain, that's different. But if I'm using a shared domain, I have to make sure this is unique. There's also an attribute called build pack, which you can optionally provide. Cloud Foundry works on the Heroku build pack model, so you can actually leverage some of those. So if you require a custom build pack, you can use the build pack attribute and specify the URL or the name of that custom build pack. If I want to see what build packs are available on an individual environment, I can issue the CF build packs command, and that'll show me all of the ones that I can reference by name if I want to explicitly pick a build pack. And again, build packs really just determine how do I handle the app that I just pushed. There's a build pack for Java, there's a build pack for Ruby and Node, and that knows how to unpack the particular components, how to stage certain things, what environment variables to set that might be application specific. All that's part of what the build pack provides. There's also a stack attribute. This is something you probably won't use very much. By default, there's a single stack within Cloud Foundry that's Ubuntu 10.04 build. But if I'm extending it, if I'm using Iron Foundry, which is the .NET extensions, for example, to Cloud Foundry, then I might specify a stack here. So I'm targeting Windows 2012, which will go ahead and push at my application, most likely my .NET application, over to a Windows environment. So I can explicitly choose my stack. And again, typically I'd only do this if I'm not doing a traditional Linux one. I can set a domain. Now every CF push deploys applications to a particular Cloud Foundry instance. And so I may be using a shared domain, like we're using now with the cfapps.io, or I could specify my own domain. So I could set up a unique one, seroder.com or whatever, pluralsight.com. I could set up my domain that I could service this thing out of. If I've mapped that to my organization, I could specify that here and say this is the domain to push this application to. There's also the concept of a host. So the host attribute provides a host name or almost kind of a subdomain in the form of a string. This segments part of that route. So if I've got a domain of seroder.com and I've got a host name of donation website, it would be donationwebsite.seroder.com. If I don't provide a host, it'll actually use the app name. So if I didn't have this attribute here, it might be donationwebsite.seroder.com. So that's a sort of relationship as you think about hosts and domains and subdomains. Those form together to create the total route that your application maps to. The command attribute is helpful and also pretty powerful. So what this does is you can use this to set a custom start command for your app. This could be, in a Node example, this could be how does Node start your app? Does it point at the app.js file? Does it point somewhere else? How should this start? I can also use this to run certain types of commands. If I want to particularly do a database migration, or I want to run a particular command line exercise on deployment, I can do that. So I can actually execute that as a startup command. This is optional. In some cases, I don't need this. For a Ruby application, for example, I don't have to set the command, but others do. So you want to be aware of what do I need to start my application for a particular build pack. The instances attribute is pretty nice. It specifies the number of app instances you want to start upon push. In this case, I'm saying 3. So ideally, you run at least 2, so you get some fault tolerance and high availability in case one node goes down. And so in this case, I can set instances equals 3. That means it's going to take that same deployment package and deploy it to 3 different instances, 3 different containers. This gives me some tolerance in case one of them goes down. This gives me load balancing if I've got a high traffic site. It's really nice to be able to pass this in on deployment time. Very foreign if you're used to doing traditional application deployment to web servers where you're targeting a specific server, and if I want to deploy to 3 different servers, I'm doing 3 different deploys versus just making a really simple attribute in your manifest. The memory one, hopefully, is pretty self-explanatory. This is where I can specify the memory limit for all instances of an application. This is per instance, so it's not in aggregate, and it's the upper limit. I might not consume this whole amount, but this is where I stop. This requires a unit of measurements. You're going to provide M or MB for megabytes, G or GB for gigabytes, and that's going to be how I can specify this. In this case, I'm doing 512 megabytes of memory allocated to each instance of my application. Now I could choose to specify a smaller limit to try to conserve my quota space if I'm bumping up against my limits, or if I don't need a gig of memory, and why set that? It's very easy to scale this up after the fact. So this might be something that you do treat fairly elastically. The path attribute lets you tell Cloud Foundry or the CF tool where your app is. Now this isn't necessary if I'm running CF push from the working directory where my app already is, but this can be helpful if I'm pushing, let's say, from a parent site, and I want to push a couple of different apps, or I want to have a manifest at one level and then just push a folder that's further down in my tree. In this case, path lets you still tell CF where my actual application is. Timeout attribute is helpful if you want to give your application more time to start. You can go up to 180 seconds here. The default time is 60 seconds. So what this means is that if I have a long warm-up time, if my application takes a long time to actually warm up and 60 seconds might not be enough, or 10 seconds or whatever I set this to, I don't want to hit timeout errors. I want to raise it up a little bit. So make sure if I have a really large app or something like that that needs a little more warm-up, I can specify that. So timeout goes up to 180 seconds. By default, it's 60. The no route attribute, and we'll talk about this a little more in the third module, but this is one that I want to treat as a background app. I don't want to assign it an internet addressable route. This is more for a worker role or something along those lines. You can specify that in the manifest so that this particular application, let's say a polling app, doesn't actually have an internet addressable route. It's something that's going to run in the background. We just played with services a little while ago and service instances. What's nice is because an app can bind to services like databases or key value stores or caches, that you can define that in your manifest. So in this case, I can specify my services in that heading and then have service instance names underneath the covers, like MyMongo or RabbitQ or things like that. These can convey, again, any sort of logical name, as we saw when we created service instances. You want this to be something fairly descriptive, not instance 1 or instance 2. This would be something you're, again, binding though to this app. So this app now has access and permission to access each one of those services. And it'll have an environment variable that gives it credentials to those services. Now, multi-application stuff I mentioned earlier is pretty wild. So I can deploy multiple apps with one CF push command by describing them in a single manifest. That's very, very handy when I want to do that. Now, as you can see, this is where the path property is going to come in handy, because I could say donation website. I want 2 instances of that. Its path, because maybe this manifest is at a root level, it's in the web directory. I have another app called Polar. I only need a single instance of that, and that's in a worker directory. So I can specify those sort of things, tell it where to put it, and all of a sudden now CF is smart enough to know and run both of those operations. It's also handy to have this concept of sharing. So when I have multiple apps in my manifest, and they might share the same settings, maybe I always do 2 instances. Maybe they're both going to end up using the database. I can have a lot of duplication, and I've got to maintain this now. If I change it in one place, I've got to change it in another. Human error becomes potentially something that's real there. So how I fix this is kind of promoting or moving up some of the duplicate content. I can take it above that application block in this example and say instances equals 2. So now every application underneath that gets that top level attribute, whether that's memory, that could be instances, that could be a service instance, whatever it might be, that promoted block applies to every application under the covers. Now, if I've chosen to put something as well underneath, I could put in my donation website, maybe I put instances equal 3. That will override anything above. So I can still override it at an app-by-app level, but I can define some shared ones that I want to default things to. At the end of the day, the whole point is to try to make this easier, more readable, more maintainable, and that's where this sort of sharing comes in handy. Likewise, I could have a manifest that describes multiple apps, but I might want to have some inheritance, so that there's almost a parent-child where I can inherit some things. I could override them if I chose to, kind of like before, but I want to break this up even into different manifests. So I could have a parent manifest like this, where I define the memory, the instances, maybe even the application name for what I care about. So again, this helps me set up my different deployment models. Each app may have its own manifest. I don't want to bundle it all up into one, but I want to have an option to parent things and deploy them together. So a child manifest uses the inherit attribute, points to wherever the base is, and it can also then override things at its own level. So it has to have that inherit line, and then it can technically do whatever it needs to. Alright, so what we're going to do next is we're going to go into our sample applications, and we're going to create that YAML file for the Node application and the Ruby application. And again, you don't have to know anything about Node or Ruby for this to work. We're just going to set the attribute values that make sense. We'll do this so when we push in a few minutes, everything will work as we expect. Here we are back in our test environment, whether this is locally in our cloud server, however you've set this up. If you look at our sample code and the demo zip that came with the course, you'll need to see in mod 2, we've got a before and after, no cheating, no going to the after. Let's jump to the before, and what we have here is the donation web, which is the Ruby front-end application that just talks to a services tier, which talks to MongoDB. And we've got the donation web service, a Node.js application that goes ahead and talks to the database and acts as that proxy. You can explore this a little more in detail. We'll talk about this as we keep progressing, but there's a custom route in here for donations. It's an express application. Pretty simple, straightforward application. Let's go ahead and in this directory, we want to add a YAML file. So let's go ahead and do new, create as a text file to start with, and make it manifest.yaml. And now let's open that up. And so this is our web service one. So this one's going to have a few properties to it. Let's type this in. Okay, so I've typed in PS donation web service. Remember, this will have to be unique, so you might want to customize this to start with, because there's a decent chance that myself or one of your fellow students has this name already in this environment. I'm setting 128 megs of RAM, a single instance, and I'm choosing my command. I'm saying kick off the file in the bin www file. That's the start command. And I'm binding it to the service mymongo. Remember that we already ran CF services and can see we have a service named mymongo in here. And that's the service I want this bound to, so I have access to this from the service. Let's go ahead and save that file. And we should see it here. Yep, there it is. Now let's jump over to the donation web. This is the Ruby-based application, and you'll see a few things here. You'll notice I create a custom model for donations, which describes the service endpoint. You'll also be able to see I have a custom controller in here, donation controller, which actually routes things to that web service upon request. At the root level, let's go ahead and add the manifest here. We'll save that. Let's open that up. This is a much simpler one. We'll go ahead and type this in. Here I'm calling it PS Donation Website, giving it one instance, 128 megs of RAM. It doesn't need to be bound to the service instance because it doesn't need to know about the database. It's a web service to web database call. It just deals with the web service, doesn't have to deal with the database. So let's go ahead and save this. So what we've created is a pair of manifests, one in each of the application layers, one in our web service layer, one in our front end, one is bound to the service instance, one is not. And now this will be easier when we push our application in just a few minutes. So what happens when I deploy an application? What's actually going on here? Let's talk about that, and then we'll actually do a deployment and see this in action. First off, at the command line, I go ahead and as a developer, I enter in the directory I want to have my app in, as we did in our Hello World example. I use the CF tool to then issue a push. I call CF push. So what happens then is that command line tool tells the cloud controller to create a record for the application in its local database. The cloud controller then stores some of the metadata, the application name, how many instances it should have, who the user was, what build pack it's using. All of that comes into play. It stores the application files. It takes the raw files that I gave it and goes ahead and stores that in the blob store. So everything that the command line tool uploaded, it goes ahead and stores that. It issues a start command. So this goes ahead to try to understand what that start command is. If it hasn't been staged already, it'll go ahead and choose a staging DEA. So if it's already running, it'll go ahead and try to just start the existing app if I didn't update. If it's a brand new application, it'll choose a staging DEA, and it'll take that DEA from the pool, stage the application using the instructions that the build pack gives it to stage it up, to actually inflate it, understand all of the settings, see what's going on. The staging DEA stages it, and then goes ahead and streams out some information. This helps the developer then troubleshoot the app or any staging problem because it's sharing what it's doing as part of its staging exercise. What's neat is the result of that. So as the staging is complete, assuming everything worked fine, it creates a little tarball, and it's called a droplet, stores it in the blob store. So now these results are cached. So the next time I want to stage an application, I can use that, or next time I want to stand up a new instance, I can just pull that information. The staging DEA tells the cloud controller that the staging is done, and the cloud controller now chooses a runtime DEA. Where do I want to run this particular application? Which instances, which hosts to put this on? The controller then goes ahead and chooses one or more from the pool to run that staged application. At that point, then the running DEA can just report the status of the app to the cloud controller, and you're good to go. So what's actually happening during a CF push is relatively sophisticated. You're shielded from a lot of that. You're not stuck actually scripting this out and tying together dependencies and testing the app out and staging it. In this case, all of that's happening for you, even to the point of you don't have to include all of the modules. Let's say if you're using certain gems or node modules, it'll actually, as it's staging it, the build pack knows to run an npm update and pull all of the, let's say, Node.js dependencies into the particular droplet. And so this is a pretty powerful tool for actually doing these deployments in a very consistent fashion. Pushing an app is really kind of easy. If I'm in the working directory and I have a manifest available, I can just do CF push application. I can pass in some parameters. As you see, I have something like no manifest. I can do that. I could pick a specific build pack. I could bind to a service instance. I can add those things if I choose to at the command line time. There's even things like choosing no route or no manifest or no host name, all these sort of things that I can choose to not even put in a manifest. I can just do them entirely through the command line. It helps to have a manifest. It makes it more repeatable, but I can do this if I'd like to. Likewise, I can even include something, if you're familiar with Git and having a git ignore, where I want to ignore certain files on my local machine, I can use a cf ignore file and say, look, I don't care about this modules folder, I don't care about this staging folder or temp folder. I can specify that as well, and the cf tool will ignore it. So here you'll see I can just do a straight up push and it just uses the manifest. I can say no manifest and just use defaults. And I can even pass in parameters at the command line time that might overwrite what's in a manifest, in this case showing I want 2 instances in my app. So we're going to do 2 exercises here. First, we're going to finish our environment build out. I've been delaying this, but now let's go ahead and make our local environment look like what Cloud Foundry is going to look like. Specifically, let's quickly install Ruby. We'll install MongoDB locally. We'll install a tool so we can explore our Mongo environment. On a Windows environment, I'll install Fiddler just so I can watch some of the traffic and submit some commands against my web service. And then we'll go ahead and test our app locally just to prove everything works before we actually do a push. This is one of those important properties from the 12-factor app where I want parity between environments, right? Dev should look like production. I shouldn't be using lightweight or different versions of services and web apps and web servers and databases. I should be using the same things. Let's get some parity locally, then we can easily see how things work before pushing it. Alrighty, we're back here in our development environment to do this demonstration. Let's build out this environment so it's got some parity. It's pretty straightforward and easy. You're going to go to rubyinstaller.org if I'm on a Windows environment to get Ruby installed. If I've got another way to push things, I'm using Chocolatey, I'm using other tools to push things to Windows, or I'm using other package managers in Linux to get things down, or Mac, fantastic. In this case, I'll do nice and graphically and go ahead and run this. I'll run the latest version of Ruby on x64, get this installed. I'm going to go ahead and make sure I add the Ruby executables to my path. Ruby's installed. Easy enough. Let's go ahead and install MongoDB. I want the Windows version here. Obviously use whatever makes sense for you. Alright, let's get this set up. Pretty simple and straightforward. Again, you don't need to be an expert in any of these technologies. You can just do typical here. I'll even do complete. Great, that's finished. I've got Mongo installed. I want to use Mongo View. It's a nice free tool for actually browsing your MongoDB. I'm going to download this. Let's go ahead and get this installed. Great, that's completed. Now the last thing is Fiddler. If I want to just explore some of the traffic going back and forth, again, use whatever you see fit for being able to send RESTful web requests to an endpoint. Great, so I've installed all of the applications I need for the environment. We should be good to go. So let's first, I'm going to have a few different command prompts open so I can open up each one of the types of applications. Let's go ahead and get our MongoDB started first. Let's go ahead and do a CD and switch to C program files. This is in a Mongo directory. And let's go ahead and create the data folder first. You have to make sure it's got a data directory. And then let's go ahead and switch to bin and start it up. Good, so I created a data directory. Switch to the bin directory, and then just issue a command against MongoD, it's .exe, that actually runs it up. So MongoDB should be started. Let's go ahead and quickly prove that before we start up the rest of our app. Go ahead and let's go ahead and find the Mongo View application that just installed. And we want to create a connection here. It's a free edition. We want to create a brand new connection here. Our server is localhost. Give it a name. Save that connection. Let's go ahead and connect. And hopefully we can browse. There's no collections in there yet. We haven't started using it yet, but we can prove now that we've connected to MongoDB. It's up and running. Fantastic. Okay, with Mongo up and running, let's go ahead and start our Node app. So I've actually done an administrative Node.js command prompt. You'll have this the command prompt installed when you install Node. I'm going to run this as admin too to make sure I can make all the updates. Let's go ahead and switch to where our demos are. These are in C demos, I believe. That's where I put mine. And we can go ahead and switch to mod 2. We're making good progress here, already on mod 2. We'll switch to before, and then go to the donation web service. This is the one that's the Node app. Now, one thing you'll notice is that there's no Node modules directory here. That's because I deleted it from what I gave you, so that you can do a fresh install. So if you do npm update, or npm install rather, it should take everything in the package.json file and install it. This goes ahead and pulls the express components, all the different dependencies that have been declared, puts those into the project. Alright, so it's got everything installed. Let's go ahead and switch to the bin directory, and then do node www to start that particular file. This more or less starts my application. So now we technically have an app running. Let's prove that. Let's open up Fiddler, or whatever tool you're using to test your connectivity. And I want to do compose. I want to compose one to my endpoint. I'm actually running this on localhost 3001. And let's say I want to issue a command to a get to donors, whatever the donor number is, donations JSON. And I do get back a 200. Good for us. There's nothing there, which would be shocking because there's nothing actually in the database. Alright, now we want to go ahead and do a post. Let's make sure we're doing the right content type so it knows we're dealing with a JSON file, application/JSON. And so what we're doing is we're sending a new record in, right? We're going to create a new donation. So we're going to post to donors/donations. We're going to make sure it's application JSON so it knows what it is. We're going to pass a JSON payload in here, donor ID 100, Noah Soroder, 5,500 donation amount. Let's go ahead and execute that. We get back a 201, meaning it created it okay. Let's now do a get. It'll ignore the payload. Let's do it against donor 100 that we just created, see what we get back. Hey, we get back a record. So let's prove that actually worked. Let's jump back into our Mongo view tool. If we refresh this, it has a single key, and it's got the record in there. So we were able to easily create that up. We got it called, and we've been doing some logging here so we can see what's coming back. So we created and we started a Node.js application that's now running. Let's go ahead now and start the Ruby application. Let's make sure we get the bundler installed. So let's do a gem install bundler so we can make sure we update all the various gems we need for our Ruby application. Once again, I didn't include everything here locally. We want to make sure Rails is available, other things we use as part of getting our Ruby app up and running. So we're getting bundler installed. Great. If we call bundle.install, I believe that goes ahead and installs all the necessary gems we need. Alright, so we've got the Node app running, we've got Mongo running, we've got the Ruby app updated. If we do Rails server, we want to start up the Rails server. This is on localhost 3000. So once this runs, we'll hit this in the browser and see if our Ruby app is up and running. You'll see if you hit localhost 3000 donations $donor equals 100, it's actually calling the web service. So I've got obviously a silly little site here that go ahead and list my donation history. Here's the one we created. Let's add a brand new one just to prove everything works. Click donate now, and 102 showed up. So I've got a donation for 100, 102. If we look at the node prompt, you'll see it actually created it. Here's 102. So now we have our entire application running locally. We have a Ruby on Rails front end that calls a Node.js backend that puts data into a MongoDB database. All of that now set up running perfectly locally. We know we've got a working app, so when we push to Cloud Foundry, we kind of have a good baseline to work with.